Hello everyone, I welcome you all to a second video on Arduino Microcontroller. In this video, we will try to connect external LED to Arduino Microcontroller, and also we will see how Tinkercad simulator can be used to simulate Arduino program. Tinkercad is a free of charge simulation software which can be used for simulating Arduino program along with other electronic circuits. So right now I have signed up to this software, simulation software, and you can see that this is the canvas where I can make my circuit, and on the right side I have the list of components. So I'm interested in simulating Arduino program, and I have Arduino Uno here. I picked and dropped it onto the canvas. Arduino is a programmable device, so I need to write a program. So I'll click code and I can choose text option. As you can see that on the right hand side, you can see the code for Arduino. And I have already explained these functions, pin mode function, digital write and delay. All the three functions I have explained in last session. Right now, first let me simulate the inbuilt LED blinking program. At pin number 13, you have an LED which is directly connected to pin number 13. So let me start the simulation. As per this program, the LED at pin number 13 should blink with a delay of 1 second. You can see that I have first configured LED built-in. LED built-in is a name for pin number 13. I can replace it by pin number 13 also. And I have configured this in the output mode. So then I am writing high signal to LED built-in, which is pin number 13. I delay it by 1 second. Then I write low. Then I delay by 1 second. And this code gets repeated. So LED will start blinking. So let me start the simulation. You can see that this LED started blinking. Now let me use external LED instead of built-in LED at pin number 13. So I'll just pick a red LED. I can change the color of this LED. And remember, when you use the physical LEDs, the forward voltage across an LED, it depends on the color of the LED. Red has the least voltage and blue on the higher side. Now, approximate voltage red LED requires is around 2 volt, and the recommended current is around 20 milliamperes. Even each pin of microcontroller can provide or receive recommended current of 20 milliamperes. At any point of time, we have to make sure that this current does not exceed 40 milliamperes. If it exceeds 40 milliamperes, that may damage microcontroller. So let me just, to limit the flow of current, I will use a resistor. I'll pick the resistor. I can change the value of the resistor. Now, right now, it is 1K. I can use the color code to find out this, or it's given here. I can just click and it shows the value. Let me use pin number 12 instead of pin number 11. So I will connect pin number 12 to resistor. Then LED has two terminals, anode and cathode. Anode is P type and cathode is N type. Cathode is connected to ground, so I'll just connect cathode to ground. This is my ground terminal, and anode to. So my connection is made. I just need two components here. One is a resistor and LED. Now what is important is for the LED, the current which flows through this. I told you that the forward voltage across LED, red LED is around 2 volt, and if current is less than 10 milliamperes, then the brightness will be low. So brightness depends on the current flowing through this circuit. If I reduce the resistance, the current will increase, but we have to make sure that this current does not exceed 20 milliamperes. Now I can calculate the resistance value by using this formula. I get 5 volt from each pin when I write I high. So 5 minus, let us say, red LED 2 volt divided by 20 milliamperes. So this will give me the value for the resistance. So if I calculate, I will get around 150 ohm. So let me just use 150 ohm here. So this is the value of the resistance. Now, I have not, my previous code, if you look at this code, this is written for built-in LED, that is pin number 13. So I need to change the code. I will replace LED built-in by 12. So I have configured pin number 12 in output mode. Then I am sending high signal, that means 5 volt to pin number 12, and delay of 1 second. Then I am sending low signal to pin number 12, that means 0 volt to this. So when I send high, the LED will be on and the current will flow through the LED. And when I'm sending low, the current doesn't flow, the LED will be off. Let me simulate this. So you can see that LED started blinking. Now if I reduce the resistance, the brightness increases. But we need to remember that, let me just stop the simulation. If I make it very low, let me just give 50 ohm. Now the value of this resistance is 50 ohm. It is green, black, black, which is 50 ohm as per the color code. So if I simulate it, you get a warning here. It is saying that this current exceeds, so it's around 28.6 milliamperes, because the recommended current is 20 milliamperes. So therefore, it is giving warning. Now, when we use our physical LEDs and the resistors, then we need to make sure that the current does not exceed 20 milliamperes. We have seen the virtual circuit simulated on Tinkercad. Now we'll look at the physical circuit. I have the Arduino Uno and the breadboard for making connections. I have 220 ohm resistor and then a red LED. Pin number 12 I use for this exercise. So pin number 12 to the resistor, then to the LED, back to the ground. So this is my circuit, the simple circuit. I have made the physical connection. Now let us look at the Arduino program or Arduino sketch. I'm on Arduino IDE page, and this is my program for blinking LED at pin number 12. I have already explained the three important functions: pin mode, which is used for configuring the pin in input or output mode; digital write can be used for writing high or low to the digital pin. Then there is a delay, which pauses the execution for specific time interval, which is in milliseconds. So I have written a program here, and as I told you, there are two important selections. One is board selection. The board has been already selected, Arduino Uno. Then the communication port. So both are selected. Let me verify the program. Program has been verified. I'm getting done compiling. So next we can upload the program into the microcontroller. The program is already uploaded. I have loaded the program into the microcontroller, and you can see that LED which is connected to pin number 12 is blinking with a delay of 1 second. But at the same time, you can also see that LED, built-in LED at pin number 13 is also lit up. So there is a reason for that. We'll discuss the reason in the later sessions. But how do I turn this pin number 13 LED low? There are two ways to do that. One is you can modify your Arduino sketch to turn this off. The second way is you can connect a 10K resistor to the ground. So if I connect a 10K resistor to the ground, let me just connect a 10K resistor, 10 kilo ohm resistor, pin number 13 to the ground terminal. And as you can see that the pin number 13, I have connected to ground terminal, the cathode is at ground. This is 10 kilo ohm resistor. So when high value resistance is connected to the ground, that means I am connecting pin number 13 to low level. So LED turns off. The second way is you can modify Arduino Sketch. You can include additional code for turning off LED at pin number 13.